In this video, we're going over design, add, and search word data structure. So design data structure that supports adding new words and finding if a string matches any previously added string. So we want to initialize the word dictionary class, we want to add a word, and we want to search for a word. So we return true if there's any string in the data structure that matches word or false otherwise. Word may contain dots where the dots can be matched with any letter. Let's go over the dot process. So the best way to search up a word or a prefix of a word will be using a prefix tree, which is also known as a trie. If you are unfamiliar with the concept of a prefix tree, I've added a link to the description below where we go over the concept of a prefix tree. Now, a side case we have to handle is the dot character. If we are currently at node X, the dot character matches any of the characters. This means we will need to check all of the children nodes of X to check if we can match the word. And this can be done recursively. Now let's go over the pseudocode. So we're first going to create our custom class trie node. So there will be two fields. One of them is children. It's hash map to keep track of character to a children trie node. And then the second one is this word is Boolean variable to indicate if we have reached the last character of a word. So basically, this word will only be set to true if the current node represents the last character of a word. This means we have found a valid word. And then the fields inside the word dictionary will be a root, so the roots of the trie, and the root does not have any characters in there, so we want to initialize the trie or initialize the roots. Now we're going to add a word, so we're going to create a variable node to keep track of our current location inside the trie. Inside trie, it will be initially at the roots or at the top of the trie. Now in iterate through the indices of word known as I, we're going to retrieve the current character C at index I. Now I want to put C and a new trie node into node.children if it does not exist. This means we're creating a new path in our trie. I want to set node to node.children .get C. We're moving down the trie. Now after we have reached the last node of the word, so I want to set node.isWord to true. It's just to indicate that this node represents the last character of a word. Now we want to search for a word, so we're going to implement a recursive approach. Now what parameters do we need? We'll need word, the input word, I, our current starting index, initially 0, and then also the node, our current location. Inside the trie, it'll be initially at the root node. We'll initially start at the top of the trie. Now what's the base case? If I is out of bound, so basically we have finished searching through the word and node.isWord is true. This means we have found a valid word, then we can return true. Now in each of the recursive call, we're going to iterate through the indices of word denoted as J, starting from I. Now we're going to retrieve the current character C at index I, or at index J. Now if C is equal to the dot character, this means we need to search through all of the children nodes of node because the dot character matches any character. Now I'm going to iterate through the children nodes, or the children nodes of node denoted as child. Now we're going to recursively check the child, our I turns to j plus 1 because we're moving on to the next character that's after C, and then node becomes the child node. Now, if the recursive result is true, we have found a valid word, we can return true. Now, if node.children does not contain C, this means we have failed to find the prefix of this word, which also means we have failed to find a word. We can just return false. And we can set node to node.children.getC. We're moving down the try node. Then we can return true if node.isWord is true. Else return false. Now let's go over the time and space complexity. For the time complexity, for the space complexity of word dictionary, we get O of n, where n is the total number of nodes of or tri-nodes. This is the trie that we're creating. And then when we add a word, the time complexity will be O of k, where k is the length of word. We visit each index once to add the word into our trie, and then we search for a word. The average case will be O of k, because we visit each index once. In the worst case, we get O of n. And where n is the total number of tri-nodes, this is because what if the word contains all dots? This means we need to search through all of the nodes. Search through all nodes. Now let's go over the code. So we're first going to create our custom class, tri-node. And there will be two fields. The first one is our hash map, where we keep track of character and also children tri-nodes. And then our second one will be a Boolean character is word to indicate if the current node is the last node in the word or not. It'll be initially false. And then we can initialize the tri-node, which is basically initializing the children hash map. We'll create one field inside the word dictionary, which will be the roots of our trie. Now, when I add a word to our trie, I'm going to create a variable node to keep track of our current location. It will be initially at the root node, then we're going to iterate through the indices of the word. And then we're going to retrieve the current character C at index I. Now I want to put C in a new node if it's absent. Then we're going to move down the trie node, or move down the trie. After we have reached the last node, we want to set node.isWord to true. Okay, now we're going to implement our recursive approach to search for a word. So we're going to recursively search the word, our starting index, and also our current location inside the trie. Now let's go over the base case. If I is out of bound, this means we have searched through all of the characters of the current word and know that its word is true. This means we have found a valid word, then we can return true. Now we're going to iterate through the indices, starting from the starting index. We're going to go through each of the characters. We're going to retrieve the current character C at index J. Now if C is equal to dots, we need to check through all of the children nodes of the current node, because C matches any letter. Now we're going to recursively check if we can find the word or not. Word, our starting index moves to j plus 1, which is the character right after the current letter. Oh, we can call this child. If we have find a word. If it returns true, it means we have find a word, so we can return true. Now, if node.children does not contain, see, this means we have failed to find a prefix of the current word. If we have failed to find the prefix, we have failed to find the word, so we're going to return false. Then want to move down the try node, or move down the try. And then we're only going to return true if the current node is a valid word. Or if the node, if our current node has reached the last character of a valid word. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.